Hi guys, in this video we are going to study how to reverse a linked list. So as you all know, linked list, what we have is like 10 is pointing to 20, 20 is pointing to 30. Like each node has two parts, one is the data part and another one is the next part, that is known as the pointer part. So we have to reverse a linked list such that the output becomes 30, 20 and 10. That is, we have to reverse these pointers such that 30 will point to 20, 20 will point to 10. So just pause the video and just think for a moment like how you will solve this problem, a nice solution, what would be the nice solution. So if we see like a nice solution, like if you don't know what a linked list is, how to traverse in a linked list, so the simplest solution would be to take these elements in an array and to reverse it, like take these elements as 10, 20, 30, take it in an array, and then what you have to do is you have to reverse it. So just print it in a reverse order. So just first of all, let's see the code of this, like what will be the nice solution. So the nice solution would be like this is the structure format of a linked list. There is a node reverse linked list. In that, in the method we get the pointer of the head node. So the head node is this one, that is the text for all these elements. So we will take a current pointer that will point to the head, and until current is not equals to null, we will loop like current is equal to current dot next. So this is the standard format if we are looping in a linked list. That is we take a current pointer that point to the head until current is not equals to null. Like in the last, it will point to the null pointer. So current is not equals to null, current is equal to current dot next. We have to add it in an array list, that is array dot add current dot data. So we will add it in an array list. So our array list will contain 10, 20 and 30. Now what we have to do is we have to print it in a reverse order. So now current will take to print the data just the same, like current is equal to head, while current is not equals to null, current is equal to current dot next. So we are looping the whole linked list. So current dot data is equal to array dot remove array dot size minus 1. What we are doing is we are removing this element from the array list, the last position, and we are adding it in linked list, that is current dot data. So current will point here, the current dot data is equals to this removed in 20 and this is 10. So this will, and in the last we have to return the head, so head will point here. But if you see the nice solution, the time complexity of this solution would be like we will need an auxiliary array. If you see, auxiliary array is needed and two traversal is needed, like we are traversing the array, so the time complexity is very much high, it is, and an auxiliary array is also required. So this is not the accepted solution. If you go for any interview, they will not accept this solution. So let's see the simplest solution or the optimized solution which we have to code. So basically, if you think, what we have to do is we don't have to like if we are taking the linked list, we don't have to manipulate the data. What we will do is we will only manipulate the pointers which are pointing to that data. So basically 10 is pointing to 20, 20 is pointing to 30. Now, if you want to reverse it, what we have to do is we have to reverse these pointers. We can say that such that 30 points to 20, 20 points to 10. So in a generalized case, what will be the case is x1, x2, x3, these are my pointers. So initially they are pointing like this, right? What I have to do is I have to point it to in the reverse direction such that this points to this, this points to this, this points to this. So looking at this diagram, it seems very simple that you have to just reverse the linked list location, but that is not so. Like before updating its next pointer, any node next pointer, what we have to do is we don't want to lose this position. Now we have to store this next position somewhere, right? Otherwise we will lose the track of these nodes. So what we will do is we will store this current dot next position in our a pointer, and then we will traverse. So let's see the code. It's very simple. Like we will take a current node, current is pointing to the head. So this is my head. So let's point the current to this. Right, previous is equal to null. If you see, like there is no previous of this, the previous is equals to null. Then what we have to do is, now when we have to do this swapping of pointers, until current is not pointing to the null. That is the last pointer. So while current is not equals to null, what we have to do is we have to first restore the current dot next. That is this position. So we will restore this current dot next position, like you can take current is here. So first we will restore this next position in the next pointer. That is, we will take a node next is equal to current dot next. That is, this position is preserved now. Now once this position is preserved, what we can do is we have to update this current dot next position with the previous array. That is, current dot next is equals to previous position. So previous. So current dot next is equal to previous. So what we have done is we have pointed it to the previous node. Now once this is done, we have to move forward to traverse all the nodes. So we'll do is previous is equal to current. Now previous will come forward to current and current will become next. That is, the next is pointing to current dot next. That is, current will now point to here. Right. So once this is done, this is an important part. Like after this all is done, what will be the head of your resultant linked list? So if you see now, if we come here, so current will become null. Current is not equals to null, and previous will point here because previous is one position previous of the current position. So this is our last node. So this will serve as a head node, like 30 is serving as the head node here. So we have to return the position of the previous. Therefore, we have to return this previous. That is, previous is now will be the new head. So this is the very simplest solution which you can code if you are being asked this question in any of the interview. Thank you for watching. For more such videos, please subscribe to my channel.